Hey guys, welcome to another math class. Today we are learning, we're doing lesson 17.3 using a Pythagorean identity. This is one of the most interesting lessons that I personally find about this topic. I love it. So let's take a look here. This is our unit circle. Has a radius of 1 centered around the origin. And if we take a look here at a 45-degree angle, or if you remember it's pi over 4. Draw our triangle, connect it down to the x-axis. This is a right angle. What have we said so far? Well, this is a 45, 45, 90 triangle. So this is going to be 2, let's see here. Let's just remind ourselves here. We know this is 1. We have an A and an A. A squared plus A squared equals 1 squared. 2A squared equals 1. Divide by 2. Divide by 2. A squared equals 1/2. Square root both sides. We get A equals the square root of 1 over the square root of 2. A equals 1 over root 2. We don't like to have a square root in the denominator. Multiply by root 2 over root 2. And we get A equals root 2 over 2. Okay, so in a 45, 45, 90 triangle, when the hypotenuse is 1, which is it is on our unit circle, we have root 2 over 2 as our A values, as our legs. Now, this is our angle here, pi over 4. If we take the sine, well, let's make an observation here. We know that a squared plus b squared equals c squared. Okay, this is always true. We're going to call this our x down here, and this our y. And applying it to this triangle, we're going to have x squared plus y squared equals 1 squared. All right, and we know x, if we want to think of sine, cosine, tangent, so katoa, x is the cosine. X equals cosine of our angle multiplied by the hypotenuse. And we know this because the cosine of our angle, theta, equals adjacent over hypotenuse, which is x over h. Adjacent is x over hypotenuse. And this equals, if we times by h times by h, we get x equals h times the cosine of theta. Well, on the unit circle, the cosine, the hypotenuse is just 1, so x equals cosine theta. And we can remember that there. We also proved that in our last video. Just to review also, y. How would we get y? Well, y is the opposite side to our angle. We're going to use sine, opposite over hypotenuse. So sine of theta is going to equal root 2 over 2 over 1. That's the same as root 2 over 2. But this is actually our y value. We can call it y over 1, opposite over hypotenuse. And y equals sine of theta. So all we're going to do with using the Pythagorean theorem, we've established that x equals cosine theta, y equals sine theta, And what we should be able to do based on these relationships is plug x and y in for x and y, and we should still get out 1. Well, let's give that a try. Then we will apply this to our specific example here. So x equals cosine of theta, y equals the sine of theta. Okay, x squared, cosine of theta squared, plus y squared, sine of theta squared, equals 1. 1 squared. And the way that you're going to see this commonly written is cos squared of theta plus sine squared of theta equals 1. When we talk about squaring a trigonometric function, we put the squared before the theta symbol. It's just the way we write it. I guess it's more clear than if you put parentheses and a squared, you could do that too, but it's more clear than just putting it after the theta, because you might mean the theta itself is squared, but it's the whole cosine of theta squared. Okay, so let's try this. We said, what if we tried that for pi over 4? Well, pi over 4 is our angle, so we should be able to plug this in for theta and get out 1. We're going to see if this is true. Cosine of pi over 4, cosine squared of pi over 4, plus sine squared of pi over 4 equals 1. We're going to see if it's true. Cosine of pi over 4, well, we said we're going to have root 2 over 2 and root 2 over 2 and 1 for our lengths. And we just established that. Cosine of pi over 4. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. Cosine of pi over 4 cosine of pi over 4 adjacent over hypotenuse is root 2 over 2. Okay, so cosine of pi over 4 is root 2 over 2, and we're going to square it. Now we are going to take the sine of pi over 4 and square it. Sine is opposite over hypotenuse, root 2 over 2 over the hypotenuse is 1, plus, so root 2 over 2 squared, and we say this should equal 1. Okay, so we're going to have 2 over 4 there, plus 2 over 4, and that equals 4 over 4. That's 1. Okay, so our trig identity works in this case. Let's do one more proof here, and then you're going to have a few to prove on your assignment, at least one or two. Okay, so we're still working with, I'm going to write it up here, sine squared theta plus cosine squared theta equals 1. And let's do a different angle here. Why don't we do this one? It is going to be pi over 2 plus pi over 6, I believe, and that's going to be 3 pi over 6 plus pi over 6 equals 4 pi over 6 equals 2 pi over 3. Okay, so we got this. Angle there is 2 pi over 3. That looks about right. Well, what is this reference angle going to be? This is going to be, well, this is pi. So if we have pi minus 2 pi over 3, common denominators, 3 pi's minus 2 pi's equals 1 pi, pi over 3. So we draw our triangle down. like that. If you remember from the notes we took last time, this is a 30, 60, 90 triangle. And across from the 30 side is 1/2. And across from the 60 side is √3 over 2. And this side is 1. Let me just redraw this here. It's getting a little messy. This is √3 over 2. This is 1, and this is 1/2. 60, 30, and 90. Okay, so what is the sign of 2 pi over 3? Sine is our y values, if we remember. Sine of this angle is going to be opposite over hypotenuse. √3 over 2. And this is a positive value, so this will stay positive. And cosine of 2 pi over 3. Cosine is adjacent over hypotenuse, so this is going to be 1/2. Okay, so now let's plug it into our formula. Sine squared of 2 pi over 3 plus cos squared of 1/2. Oh, this is 2 pi. Let me back up here. Sine of our angle is √3 over 2. And we're going to square that. Cosine of our angle is 1/2. And we're going to square that. And according to our Pythagorean theorem identity up here, this should equal 1. Well, let's test it out. √3 over 2 squared is 3 over 4. Plus 1/2 squared is 1 over 4. 3/4 over 1/4 equals 4/4. Boom, done. Okay, so these are how trig identities work. Actually, this should be a negative 1/2, shouldn't it? Because this goes out to the left from the origin, our x value goes out. But when we square it, the negative cancels out, and that is why we still got the correct answer. Okay, so hopefully that is helpful for you. And let's see, we can have some other basic identities from this up here. We can solve this for sine and cosine. Sine squared theta plus cosine squared theta equals 1. Let's solve it for sine. It's going to be 1 minus cosine squared theta. Just subtract cosine squared theta from both sides. Take the square root. Sine of theta equals the plus or minus 1 minus cosine squared theta. Okay, this is something we will remember. We can also do this with cosine. Sine squared theta plus cosine squared theta equals 1. So we'll have cosine squared theta equals 1 minus sine squared theta. Square root both sides. We're going to have cosine theta equals the plus or minus square root of 1 minus sine squared theta. And this is our next trig identity that we will be using.